Hi, welcome back. In this video, we're starting to get a little bit more complex with the Seqera Node-RED plugin. We're going to introduce some additional node types to work with data links, which is to do with looking at files on your storage through Seqera Platform, and also Datasets, which is a way of maintaining and keeping metadata within Seqera Platform. This is all documented on the plugin website here under Add Datasets and List Files, and we'll be talking again about the launch and monitor workflows. Also poll files. Okay, so if I go into my Node-RED instance here, and again, I'm going to work off one of the example flows. So I go to Import, Examples, Node-RED Seqera, and I'm going to click on Launch on File Upload. This is a very, very common kind of flow that many people find themselves doing in genomics NGS sequencing. And basically the overview is we are going to look at our storage using the Seqera Platform Data Link. And we're going to keep inspecting a particular location on the storage to see if any new files are uploaded which match our use case. If there are new files, that will trigger an event which will hit the next node type, which is called list files, which will, very, very similar to polling, will just return information about a specific path via Seqera Platform Data Links. Then we have one of these custom functions with a bit of JavaScript, some logic to build ourselves a sample sheet. The sample sheet is then saved to Seqera Platform as a dataset, and then the dataset is used to launch a workflow which is monitored. Quite a few steps in this one, several different Node-RED nodes that we're using from the Seqera plugin, but hopefully quite a realistic workflow here. We don't have any inject or debug nodes, this is all kind of real life. So let's click in and look a little bit about what they're doing. Firstly, if I click on poll files, this is one of the more complex ones we have. I need to set a Seqera config. And then if I go into my Launchpad here, I can go to Data Explorer and I can see all the different buckets I have set up to be accessed. These are mostly AWS here, but I could set up Azure, Google, or any S3 compatible storage here. So I have a feeling I work a lot with NF Core, and I think I have one called AWS Megatests, maybe. Yep. So I have a bucket called that. I'm going to look for that, and again, it auto suggests as I talk, as I start typing here. Hopefully, there you go. So it's found it there, and I can select that. Right. The other fields here are quite important. By default, in this example, it's looking at the whole base bucket, S3 bucket, but I can type in, for example, I don't know, sequencing results as a path, for example. Filter whether it's going to tell me about files or folders or both. In this case, I just care about files, and I'm going to look for a prefix, which is basically a file name at this base path. In this case, as the example has rtacomplete.txt, which is a standard used by Illumina sequencing machines that when they've finished uploading all their files and depositing all their files from a sequencing into storage, this empty file is created as like a signal that everything is ready for downstream analysis. So once this file exists in a directory, we know that all the other files from the sequencing are also there and they're ready to go. I can also set up different things with like a regular expression here. This is preferable to use a prefix because that's done server side. If you have big buckets with many files, it's more efficient. The regular expression after the whole list is returned from Seqera Platform, it filters there. And then importantly, we also care about maximum results returned and the depth, how many directories of recursive searching we're going to do from this base path. So if possible, we don't want to do any recursive searching, so we'll leave that at 0. And hopefully there's not going to be loads and loads of files in this bucket, so we can leave this as 100. But if you put this to a much higher number, then the Node-RED node here will automatically run through all the different pagination results from the API until it finds what it wants. Okay, it's going to check this every 15 minutes. Every 15 minutes, it's going to look in the same path. And the way that this node works is as soon as I click deploy, it's going to run this node once and get a file list. And nothing happens on that first check. And then every subsequent check, every subsequent poll, it compares to the previous one to see if there are any differences. And if there are any differences since the last time, it will output them. Okay, I'm clicked on help top right, and it tells me about this node here with all these different inputs that I've just told you about. And you can see the output here is we've got payload, which basically just has everything from the API. So for maximum flexibility of downstream usage. And then another kind of convenience variable called message.files, which is an array of file names which are new on that poll. Okay, we now have a list files one. So this is another Seqera Node-RED node here, which is very, very similar, but you can see poll files doesn't have any inputs because it just runs as soon as you click deploy, it just starts running. Whereas list files only runs when it gets an event. And the reason we have this here is that it's configured slightly differently to the poll files. The polling files is only looking for that Sentinel signal file, that RTA complete. But actually, we don't really care about that file. We just care about the fact that it suddenly exists. Once we know it exists, we can then configure this to go and look up all the FastQ files. So again, I can configure this to NF Core AWS megatests and sequencing results or whatever it was. And now I'm using a regular expression to look for any file name that ends with .fastq.gz. And this will again give me all the different outputs as the payload or as an array of file names. So this is what I'm actually care about, is the FastQ files. So that's why we have one and then the other. That event triggers a list of files. The list of files is then passed on to this custom function. This is some simple JavaScript. Don't feel too worried if you're not familiar with the syntax. But basically we're getting this array of file names here. And then we've got a simple loop that kind of goes over and inspects what the file names look like, whether they're grouped or not, and tries to group them by paired end sequencing, basically FastQ1, FastQ2. And then it sets strandedness to reverse with a static string. This is the kind of thing you can write with an LLM very easily. And then at the end, it joins all those arrays together and returns it as a single string. Okay, that's passed out as the message. And in here, we have a final new node, which is add dataset. So again, I can configure the config. I can configure a name here, my test dataset. And as the contents, the file contents, it takes message.payload, which is the output from a previous node. Type CSV, and I can choose whether it has a header or not. In this case, it does. I haven't mentioned this before, but all of these nodes have a workspace ID. You can just leave that blank because we've set that as a default up in the Seqera config. But if ever you want to customize that or do that dynamically, you can in these nodes. Okay, so this sample sheet will be created dynamically by Node-RED, and then this will save it, and it will show up if I click Datasets here in Seqera Platform. It will show up here where I've inputted different things here. So we get these nice metadata tables which are versioned and trackable within Seqera Platform, much more rich than just a file sat in S3. The dataset node then has different inputs and different outputs. Here again, we've got payload, which has everything, and message.dataset ID, which is the ID of a dataset that was created. And we can refer to that here, where we can say the input for the pipeline is the payload from a previous node, and I've set version.url, which is one of the results from the API. So I'm dynamically telling the pipeline input to use the data set that we just created dynamically, which is super cool. The workflow gets launched, and then we monitor it, and then we can do whatever we like with that pipeline when it finishes. Okay, I hope that makes sense. Bit more complex, kind of following all the logic through, but like I say, this is quite a realistic, real-life pipeline. So I'm hoping that many people will be able to take this example, walk through the nodes like I just did, configure it to your particular infrastructure, and then maybe build off it and extend it. Hope it's useful. Come back for the next video and we'll talk about some of the additional nodes that we have in here.